Can you hear me? Yes? Can
Yeah.
someone? Thank you so much. Okay, so we during before the break, we spoke about strain hardening. Okay, then the A value could determine whether to use minus 20 degrees or plus 15 degrees sort of rake angle. Okay, so the thing now is this. Uh, what do we mean by negative rate angle and what do we mean by positive rate angle? Okay, so what I'm going to do for the next 40 minutes, okay, is to define what is a positive negative rate angle, and then we're going to apply the mechanics of metal cutting to explain what are the consequences if you use negative rate angle, what is good and what are bad, or if you use positive rate angle, what are going to be your the consequences. So there are two rake angle configurations. Okay, so we're going to draw them now. So I'm going to draw the straight line. Okay, a horizontal straight line. Then two vertical lines. I need more space on one side, sorry. Okay, so this is a positive rake, negative rake. Okay, what does it? So positive rake angle, it looks like this. I have problem drawing straight line today. So these are two. This alpha. And that's what we call a positive rake. Okay. So in both of these diagrams, the material will flow this direction. So this is the cutting speed. Okay. So the material hit the two from this side. And then negative rake looks like this. Okay. So this angle over here is your alpha. So that's what we call negative rake angle 2. So this is our 2. So on your left hand side is positive, on your right hand side is negative. So if we look at edge strength, can someone tell me which one has a better edge strength? Means what edge strength means what? The cutting edge is more stronger. Which one? The positive or the negative? Anyone? You can call a friend. Yeah, the positive better? No, it's worse. Okay, so this has poor edge strength. Okay, and this has excellent edge strength. Okay, and why is that? Is because the angle between is this angle over here. The angle between the rake angle and the clearance angle. This is usually less than 90 degrees. Not usually, always less than 90 degrees. Over here, look at this angle over here. Okay. So this over here, this angle over here, the angle between the rake face and the clearance face is greater than what? 90 degrees. Okay, so it has excellent edge strength. Okay, now if we look at two material, right? If we look at two material, so not workpiece, yeah. Two material. If your two material is soft and ductile, right? You will use positive rate angle. So for example, are your high speed steel material. Two material, okay? Okay, are your high speed steel. So negative rate angle tools, the two material are usually hard, usually hard and brittle. Okay. So what the things are like cemented, tungsten, carbide. Okay. Or your polycrystalline, cubic, boron, nitride. In short, PCBN. Okay, you tend to use negative. Why you need brittle material? You need negative rate angle, so you have better edge strength. Then it can withstand the stress. If you use brittle material, use positive edge strength. Once your material hit the workpiece, it will fracture. Okay, so forget it. Okay, now in terms of workpiece material, I'm going to carry this over. Okay. In terms of workpiece material, okay, in terms of workpiece material, based on the A constant. Okay, so on one side, we still call this positive rake, and then we have negative rake. Okay, so for the positive rake, you usually use for low A value. Okay, so low A value materials. Okay, so they are usually soft and ductile. Okay, so you can use positive rate angle tools. Okay, so we usually, when you machine aluminum, copper, brass, okay, and sometimes annealed or fully annealed low carbon steel. You can use positive rate angle too. Okay, negative rate angle, so you'll be high. Okay, high A value. Okay, so basically material with high hardness. We tend to always use negative rate angle. So the hardness, as long as the hardness is greater than 35 Rockwell C scale, okay, you have to use negative. Use positive, good luck. Okay, so example, Inconel 718, okay, or any hardened steel. You are better off using negative rate angle tools. Okay, so as I mentioned earlier, okay, and I've shown you, okay, so negative rate angle tools. Okay, rate angle tool is able to withstand higher stresses because the angle between the rake face and clearance face is larger, right? Is larger, right? When compared to what? Positive rake angle. So now we now know. Okay, so Eugene say, hey guys, if you have workpiece is hard, you use negative rake. Okay, but now I'm going to tell you the consequences. Okay, if you use positive or negative rake, what are the side effect? Okay, side effect. So we're going to look at a side effect based on the mechanics of cutting. Okay. Yes. Anyone? Any questions so far? No. Okay.
Eugene,
Yes.
will the effects that you're going to describe now, are they going to be similar if the tool is worn out? Or what type of effects would you see?
Can you repeat your question, please?
If the tool is worn out, for example, what kind of effects would you see?
So what I'm doing over here is to based on mechanical properties, select the two rake angle process parameter so that the two wear rate will be lower. There's no way to get rid of two wear. Everything will wear, yes or no? Right? So when the two is worn, what will happen is your forces will increase, your temperature will increase. Does that make sense?
Yeah. Okay.
Okay.
Thanks.
Right. So the next thing we're going to look at is the effect, the effect of two rate angle on the mechanics of cutting. Okay, on the mechanics of cutting. So I will start sketching trends. Okay, all these are trends, well-known trends. Okay, from experimental work. Okay, so this is the x-axis is always the rate angle. You have zero, you have negative rate, positive rate, and the first thing we are going to look at is cutting forces. Okay. So from experiment, we know that whenever we use negative rate angle, we're going to have higher forces. Okay, later on, we'll explain why the higher forces. Okay, so when using negative, okay, negative rate angle tools, all right, cutting forces will increase. Okay, but remember, these are over here, right? The hard material is what a lot of people want to use now. Okay, you don't see a lot of, I mean, you still get materials made of aluminum, copper, and brass, but if you want high strength, you have to go to the high A value, yes or no, right? So to machine things they are very hard to machine. You have to adopt to what? Negative rate angle tools. However, your cutting forces will increase. So when your cutting forces will increase, this will affect what? This will affect deflection. Okay, deflection of the tool. Okay, will affect the and mechanical vibration of the entire uh, mach- uh, machine structure. So the machine structure over here is the lathe. Okay, the lathe is a machine tool for turning. Okay, so we are talking about turning. This is also applicable for milling. Okay, so one more effect that were okay. So hold on. So these are the cutting. Okay, let's look at this first. Now, so it affect the deflection of the two mechanical vibration of the entire system, entire machine structure. So usually modern tools right? Modern lathes that you buy after the 60s, they are more rigid than before. Okay, now I'm going to sidetrack you guys a bit. Okay, which are the three countries that we know built